Welcome, dear readers, to the captivating realm where quantum mechanics intertwines with the age-old question of mortality. Prepare to delve into a concept so bizarre, so mind-boggling that it seems ripped from the pages of science fiction quantum immortality. Imagine, if you will, a reality where death, as we know it, ceases to be an absolute endpoint. A reality where consciousness persists, not in some ethereal afterlife, but rather by hopping between parallel universes. This is the essence of quantum immortality, a theory that has sparked fascination and skepticism in equal measure. In the following sections, we'll embark on a journey to unravel the intricacies of this perplexing theory. Fasten your seatbelts, for our exploration will take us to the very limits of human understanding. Before we can grasp the enigmatic concept of quantum immortality, we must first familiarize ourselves with the fundamental principles of quantum mechanics. In the subatomic realm, the laws of physics as we know them break down, replaced by a set of rules that seem counterintuitive and downright strange. One of the central tenets of quantum mechanics is the idea of superposition. Unlike everyday objects, which exist in a definite state, particles at the quantum level can exist in multiple states simultaneously. It's like a coin spinning in the air, both heads and tails at the same time until we observe it and force it to collapse into a single state. This inherent indeterminacy extends to the very fabric of reality itself. At the quantum level, the universe exists as a sea of probabilities, with countless possibilities unfolding simultaneously. It is within this mind-boggling framework that the seeds of quantum immortality are sown. Quantum immortality stems from the mind-bending implications of the many worlds interpretation, a controversial yet increasingly popular interpretation of quantum mechanics. Proposed by physicist Hugh Everett III in the 1950s, the MWI suggests that every quantum measurement or interaction spawns a multitude of parallel universes. Imagine, for instance, that you're faced with a life or death scenario, such as a car speeding towards you. In our everyday understanding, there are two possible outcomes. You survive or you perish. However, according to the MWI, both outcomes occur, but in different branches of reality. In one universe, the car swerves at the last moment and you live to tell the tale. In another, perhaps the car doesn't swerve, and your consciousness ceases to exist in that particular reality. However, proponents of quantum immortality argue that your consciousness, your subjective experience, doesn't simply vanish. Instead, it continues in the universe where you survived. The many worlds interpretation, while mind-boggling, offers an elegant solution to some of the perplexing paradoxes that plague quantum mechanics. For instance, it explains the puzzling phenomenon of wave function collapse without resorting to arbitrary distinctions between the quantum realm and the classical world. According to the MWI, there is no collapse at all. Instead, every quantum measurement or interaction causes the universe to split, with each branch representing a different outcome. These branches, once split, continue to evolve independently, creating a vast, ever-expanding multiverse of parallel realities. While the MWI remains a subject of intense debate within the scientific community, its implications, particularly for the concept of quantum immortality, are nothing short of astounding. If the MWI holds true, then death as a definitive endpoint might be an illusion, a mere transition between parallel worlds. A coin toss in the multiverse. To illustrate the concept of quantum immortality more concretely, let's imagine a thought experiment involving a hypothetical quantum coin toss. This coin, unlike ordinary coins, operates according to the principles of quantum mechanics, meaning it can exist in a superposition of both heads and tails until observed. Now imagine that a volunteer agrees to participate in a potentially lethal experiment. The rules are simple. A quantum coin is tossed, and if it lands on heads, the volunteer survives. If it lands on tails, however, a device is triggered, ending the volunteer's life. From the perspective of an outside observer, the outcome is straightforward. There's a 50-50 chance of survival. However, from the volunteer's subjective experience, something truly remarkable occurs. Every time the coin is tossed, the universe splits, creating two parallel realities. Life, death, and infinite possibilities. In one reality, the coin lands on tails, and the volunteer's consciousness ceases to exist in that particular timeline. However, in the other reality, the coin lands on heads, and the volunteer survives to witness another toss. This process repeats itself with each toss, with the volunteer's consciousness continuing only in those universes where the coin lands on heads. From the volunteer's perspective, it would seem as if they are incredibly lucky, surviving an improbable number of coin tosses. In reality, they are experiencing the strange logic of quantum immortality, their consciousness hopping between parallel universes, always experiencing the outcome where they survive. Of course, this thought experiment raises profound philosophical and ethical questions. If our consciousness persists across parallel universes, what does it mean to truly die? And what are the implications for our understanding of free will and determinism in a multiverse where every possible outcome occurs? Experimental evidence and counter-arguments. While the concept of quantum immortality is undeniably intriguing, it's essential to acknowledge that it remains highly speculative. As of today, there is no direct experimental evidence to support the many worlds interpretation, let alone the notion of quantum immortality. Moreover, the theory faces several significant criticisms. Some physicists argue that the MWI violates Occam's razor, the principle that the simplest explanation is usually the correct one. The idea of an infinite, constantly branching multiverse, they argue, is simply too extravagant and unnecessary. Others point out that the MWI fails to address the preferred basis problem, the question of why we observe a particular set of outcomes rather than an infinite superposition of all possibilities. Despite these criticisms, however, quantum immortality continues to capture the imagination, fueling ongoing debate and speculation. Quantum immortality, while firmly in the realm of theoretical physics, offers a tantalizing glimpse into a reality that challenges our most fundamental assumptions about life, death, and the nature of existence itself. Whether it proves to be a scientific dead end or a revolutionary new understanding of our place in the cosmos remains to be seen. One thing is for certain: the exploration of such mind-bending concepts pushes the boundaries of human knowledge and inspires us to confront the profound mysteries that lie at the heart of our universe. Thank you for joining me on this journey into the strange and wonderful world of quantum immortality.